Alrighty, well, welcome everybody. It's great to have you here, and we're really excited to have Brandon Weiss of Dvele here to present about offsite passive house projects. So, a little bit about the Passive House Accelerator. We're a collaborative online platform for sharing innovation and thought leadership in passive house design and construction. We publish articles and interviews. We produce weekly virtual confabs with passive house pioneers from around the world, like tonight. And we elevate the work and programming of the passive house movement's leaders, practitioners, and organizations through interviews, articles, social media campaigns, videos, and podcasts. Our aim is to catalyze zero carbon building by accelerating the adoption of passive house building. With our co-hosts, Sean St. Amour, Kevin Brennan, and Mark Willey, we have launched Construction Tech Tuesday to share the technical, the technique, and the technology of passive house construction tech. Each week, we'll welcome guest practitioners to dive into the details of practice with the builder and tradesperson as our target audience. We welcome folks from all corners of the construction and design world to join us each week, and we're very happy that you're here tonight. Thank you.
Guys, welcome to Tech Tuesday. Kevin Brennan here from New York City. It's a nice gloomy day, some snow on the ground recently, but I'm very proud to have a friend from summer camp. Summer camp was so good that I had a foggy remembrance of like, I know that dude. How do I know him? But the building science was fun. And then last night in the warm up, we really got to know Brandon and the work that he's been up to. And the technology is going to blow you away. And the techniques in the building science, I'm sure, is going to keep you guys strapped to your seats. So it's great to see that the market of California is getting passive houses that they need, and in areas that need them, and you'll learn where they're going. And as a fireman, it's great to see that places that have been ravished by fires are being rebuilt in a very responsible way. So I'm Brandon. Keep innovating, my friends, and I look forward to the presentation.
Hey everybody, I'm Sean St. Amour, and I got a little helper tonight. So I'm lucky to have an amazing and supportive wife and two wonderful girls. And Darren, who is my youngest, she has some spelling words she's working on this week. But guess what they start with, everybody? They start with
PH.
This is the homework. See it? So I got in trouble because our teacher's telling me that that they got to switch things out, and I'm like, everything's PH. There's no F in the alphabet. So I got in trouble. So hopefully we'll continue with the banter with PH because it's all about passive house. So Darren, say over to you, Mark.
Over to you, Mark.
Thank you, Darren. You're wonderful. And don't forget to spell February with a PH.
I will.
Wonderful. Sean muted you, sweetheart. Everyone watch out. She is soon to be the youngest passive house tradesperson out there. So I met Brandon a long while ago in the construction industry of Chicagoland, and got to see the solution that he created for himself and his team and his projects from jumping into LEED, being one of the first builders in LEED, one of the first builders in Department of Energy, definitely the first passive house builder in Illinois, and later on Living Building Challenge. But Brandon likes to continue to go beyond and challenge himself and pick up inspiration from the industry. And so he uprooted himself from the Midwest. We had a heartfelt bon voyage, and he landed in this place called California. And it's on, as Sean would call it, the Pacific Coast. Some people still refer to it as the West Coast. Very odd. But anyway, he got into this thing called offsite manufacturing. And for many of us on this call, it's very dear to us. But he did something very special. He took his passion for passive house and building science and integrated it with the offsite community. I know to many of you that's wonderful, and that's what you came here for. So my mic is now off, and I hand it to you, brother.
Thank you so much, Mark. Great to be here. Thank you for everyone for logging in tonight. We'll get my slides here loaded.
The other thing I didn't comment on, Brandon, and for the audience is after the first hour, once we take a break and review the Q&A, we will then be showing a video as well. So if you think the presentation is awesome, which you will, hang tight, because in the second hour, we have a kick butt video from Brandon and our friends at Dvele.
Thanks, Mark. And, you and I did actually meet in the West Coast of Lake Michigan, but, I guess it is proper to call this the Pacific Coast. So as an introduction, Dvele is a high design, high performance technology company that is scaling energy efficient, self-reliant, human health and wellness centric homes through an offsite modular platform with attention to quality and product and process throughout the entire company. And that's really our focus, is that scalability solution. All right, so we've developed a company and a technology to drive the industry, as many of the passive house world are doing consistently, and also trying to have a positive impact on the world. That's, the environment and the clients of our homes, the communities that our homes are built in. We are kind of looking at what is the evolution of home and having a self-powered, health promoting, and a home that can consistently get smarter over time. We'll talk more about that as we get into it. It's also digitally native, automated processes, and looking at, kind of the whole ownership model. And, as a company that's doing modular homes in a factory environment, we actually are the single source of accountability to our customers too. So we're handling all the engineering, the design. We are taking that through the manufacturing process. We're managing the site process and the stitching, as we'll get into a little bit later, and delivering that home to the client. And so just looking at that as a holistic process, which is not always the norm in the offsite construction world. There's 3 different ways that people can own or develop, that we sell Dvele homes. One is direct over the internet to a buyer directly. Second is developer partnerships. And then third is spec homes that we've produced. To date, all of the lots and the properties that we built and have done spec homes on were fire rebuild zones. So it was an initial plan to try to do some specs on our own, kind of practice on ourselves before, having clients that we're going to work through a customer experience process. But we wanted to do something to give back to areas that needed it too. And in California, there's definitely, that happened a few years ago when we were first acquiring these lots. And looking at positive impact, probably something people are familiar with, just, per 1,000 Dvele homes, we can have carbon savings of 2.7 billion pounds, and many other metrics that, again, just looking at things more holistically, and how can we create better homes, but also better ecology and a better planet. So the process begins early on, and one of the unique things is the design process. So one of the cool things that for me, coming from the site built world and having a set of plans, and it went from early in my career seeing plans that were 15 to 20 pages to scaling those up to 50, 60 page sets. But now getting into 3-dimensional BIM modeling and having the opportunity to look at all the mechanical systems at once and ensuring that you're not having conflicts or collisions, both with the structure itself and other mechanical systems. So that's been a really cool part for me, to be able to see that, and helping design some of these systems, to be able to look at that holistically and look at it all together and make moves that change and are completely interactive. One of the unique things about Dvele is kind of how we view our product. So we have standardized sub-assemblies and systems that we've designed to achieve mass customization. So looking at it as kind of that computer chip, we have our structural system, we have our self-powered system, that ties from our building assembly to our performance metrics, all the way into all the electrical appliances and mechanical systems, and the battery and solar. We also have our health and wellness features, finishes, and the Dvele IQ, which we can talk about a little bit later, which is our home automation platform. When that all comes together, we're able to kind of take different products and kind of create them into our standard, I guess. So one of the first opportunities we had with this was back in May of 2020. We had acquired Blue Homes, and we're looking at, they had some really great designs, and we wanted to take those designs, put our inputs into them. So our performance metrics, our wall assemblies, our mechanical systems, and create Dvele inside of Blue. So Blue will continue to be a product name and brand, but it will be powered by and have kind of the Dvele inside. So all the performance metrics and things that we hold near and dear are getting included and incorporated into that product line. So you'll see at some point like a Breeze house that has all the Dvele features in it. And there's over 140 different variable inputs that we can change, and putting that into that holistic system, create an efficient way to produce these homes with that many different variables. This is a rendering using that same software. We get into the photorealistic renderings. This is a development that we are working on in Northern California. You see Michael running down the path there. He's on the porch there, Kevin.
Yeah, Mike's on the porch there. He's running, and I think that might be his dog too.
Very nice. Thank you. It was a wonderful run.
Cheers, everyone. Cheers.
Mike, you going to Tahoe recently, or when you going?
Yeah, I'm there now.
All right, so that takes us into kind of after the design is done, and we start a production. Our factory, we call it our foundry, and that's where we produce our homes. So we own our own production facility, our own factory foundry, and produce all of our homes there. Currently, that's in Loma Linda, California, which is in the Inland Empire area, so kind of between Los Angeles and Palm Springs. And then our headquarters is down in San Diego. This is a picture of that facility from the outside. So one of the interesting tidbits there is Loma Linda, California is actually one of the 5 blue zones in the world where people have the longest lifespans. Not that we can claim anything to do with that, but I think it's pretty cool that we're building homes that have health and wellness features in them and get to build those in kind of a cool area like that has that moniker known worldwide. And as on many Tuesdays here, it's been discussed, mock-ups are a great way to start this whole process, right, of building something new. So we acquired a factory that had been in business for 40 years. A lot of those employees stayed with, and there was a lot of training that needed to be done to bring them up to the level of performance that we were integrating into Dvele. So this is an earlier on photo, but just being able to walk people through and have them actually physically do these mock-ups to show the different layering and how things get incorporated together was definitely a critical part of the process. And we've done several assemblies like this throughout. And then this is showing an exterior. So this is on the production line. Our homes get drywalled on the table. And so when we tilt them up, put them together and make it 3-dimensional, our electrical can get done from the outside, and then our insulation goes in. So we have the Rockwell bats that go in there, and ensuring the 6 sides of contact to make that all work. All of our homes are structurally engineered for the site specific. Mainly, most of them are going to California and high seismic zones. But we also are building homes and have clients in Colorado. We have prospective clients in Utah, kind of those ski resort or winter towns that have short building seasons and limited labor pools. It's a good value proposition for our product line. This is showing kind of one of those sensors. So I mentioned, and we'll get into it later again, but this is just locating one of the sensors that is in our wall assemblies. This is a temperature humidity sensor, and we like to put those throughout the assembly, kind of loading up our homes with the hardware, taking a similar approach to Tesla. We put the hardware and then the software updates can come later. We are currently pulling data from these sensors to ensure the buildings are performing as they were designed to. So it's great to model things, but getting those real world performance is something that I've been passionate about for a long time and started about 10 years ago. And definitely something we're scaling up here at Dvele now that we have some software engineering teams and other teams in place to really make the best benefit of that. And then we start putting up our exterior sheathing. So you can see here we have our liquid applied coating over our struck one plywood. That's all pre-coated before we put it up. So we pre-finish it, do as much flat as we can to make the most efficiency and best use out of our assembly line. And also this is one of those things that we talked about sub-assemblies earlier. I mentioned that. This is one of the things that would get built as a sub-assembly. And then just brought to the production line as it's needed and put up and installed. And then you can see all the sheathings up on this project here at this point. We have some window flashings in there, have started, taping that. So there'll be a bead of the Persoco joint and seam over the top of that flashing. And then we'll put the blue skin tape and then come back with another bead of the joint and seam on top of that, just to have redundancy and make sure we have plans in place in case anything were to fail in the future. So, and you can see we're lifting up these sheets of, these are actually geofoam. This was an earlier version of our product line. So we were putting that up on the roof as our insulation. So we have an unvented roof assembly. So we have our structural ceiling that gets dense packed. And then we have, now we're using SIPS panels just to make it a little more streamlined. And we also get larger overhangs and things like that. We'll see some of those in the future shots, but this is loading up that geofoam that we had kind of shiplap the edges on there. And then our continuous exterior insulation goes on after that. So ensuring that, you know, everything's been sealed. We do a pretty thorough QC process on that before going on to that next phase. Everything's inspected, photographed. So we have that backup and understand the layering of the building. If anything ever were to happen in the future, we have that documentation in place. You can see this mainly, you know, is our exterior insulation. We also get some radiant barrier properties out of it as well. And then works as our primary weather resistant barrier. So the Pro Soco behind it can also serve as that backup, that redundancy in terms of weather resistance. And that Pro Soco obviously was our air control layer. And then as things progress, you can see more holistically. This is something we used to do, and you saw in the previous picture as well. But when we were younger as a company, we had more room in our facility. We were able to kind of dry fit these modules together, ensure the openings were lining up, making sure floors were leveled. We actually were laser multiple points and write that down as documentation for when we went to the site, so we can understand how it's set up in the factory versus once it's set up on the foundation. And, you know, we laser level all of our foundations as well, previous to the homes arriving. But now we're moving into a more single line production facility where we won't have that luxury, but it's kind of cool that we had that opportunity at one point to do that. Here you can see we have the core event and our furring strips going up. So next step in the process, and kind of hard to see in the picture, but we actually do wrap our core event in an ember resistant screening material, because building in California, we want to have that fire resilience and ensuring that's all in place. So the continuous exterior insulation we're using is an FPA 285 and ASTM 84. So it does have the fire resiliency there. And then, you know, layering it on with our latter parts of our assemblies and our cladding to make sure we keep that intact. And then the cladding goes on after the rain screen's up. So you can see we do both metal siding as a standard, and then we have a wood siding as well. We put the wood up, we actually have a backer on that too to thicken it. So it's actually a 1.5 inch thick assembly, again, to boost that fire resiliency and bring it up to the WUI fire codes. This is a tile installation. You know, not much for this crowd really, but just it's kind of cool. You know, doing this in the field, you know, it'd be a more painful process from my past experience, but you know, now having a station on the assembly line where the tile happens, you know, all these parts and pieces are readily available, easy to use, and it just as easy as installing tile on a normal everyday purpose, I guess, but now can add some of the cooler technologies and stuff like. Not that you couldn't do that on site, but you know, it's having that control and having that station all set up is pretty nice. You know, one of the things I found is building in a production facility like this, we're able to, you know, usually when your crews come to site, in the site world, it was, you know, 15 to 20 minutes at the beginning of the day, unpacking tools, rolling out, plugging in extension cords, getting fired up. And the same thing on the back end, you know, not just the cleanup portion, but actually putting those tools away, putting them back in their trunk. So, you know, it saves a good chunk of the day, maybe 10% of the day, just not having to do that every day too, which is pretty neat. Guys roll in, they have a morning meeting, they do a stretch together, just to get loose and start the day. And the production manager will go over, you know, kind of the main focal points of the tasks for the day there for them. This is a kitchen and just kind of showing you the interior of what one of the modules looks like on the line. You can see here is a marriage line. That's where two modules come together. We've held back the drywall there so we can bridge that on site. We'll, when it gets to site, we'll also put a backer rod back there and then tape that, and then structurally attach as well between those modules. And then here, these ceiling access panels are left open. Usually we try to do this incorporated where there's already drywall work to be done, but that's a sprinkler crossover. All of our homes come with fire protection built into them as well. This is a shot of the mechanical room. So I know this crowd definitely wants to see some of the mechanical systems. That's our whole house water filtration system. So multi-level filtration. Then we have the UV filtration there. You can see part of our heat pump hot water heater and our recirculation pump there as well. There's two different shots of just some different ERV installations that we've done. So definitely a core piece of what we do, making sure that every single home gets this and gets it completely balanced and distributed throughout the home. Should give a shout out to Sai Safi if he's in the crowd. He helped actually helped me install this one on the right. This is going back a couple years, but did that in the field out in Colorado together. And this is a module, all shrink wrapped and ready to ship. Got our branding on there and our access hatch, so when it gets to site, people can get in there and start pulling off the plastic and prepping it for the crane. So we'll get into the crane, and stitching is what we call our process. Once we get to site and we've landed everything, structurally attached it, it's when we start sealing it. So a lot to do with the air barrier and air tightness that we're doing, the thermal layer, all that stuff is part of that stitching process. This is a foundation, so it is ready for the modules. You can see we have a ICF wall here. We also have 2 layers of insulation underneath our slab, giving us R10 there. And we like to put in a lot of the big components that go in the crawl space. So the trunk lines for our heating and cooling system get attached to the underside of our floor structure once we land that. So put that in there so we can keep it in long lengths, make it easy to seal. A lot of the joints are already pre-sealed where there's end caps and things like that on there. And just makes it easier to put up later. You see we have our ERV tubing here, and then also some long length waste pipes for our plumbing system. So put all that down there, and then the mods start coming in on top of that. Here's some chairs our customer experience team had set up for customers, and so they could supervise the crane day operations. These placards, these are inspired from NFL coaches having like the play cards that they're constantly running plays from. So it has times, sequencing of all the modules when things are getting unwrapped, set. So we have that game plan laid out, before the day starts, and kind of the customers enjoy kind of following through with that. Typically the first one's in the home once they've been set. So, most people are quite excited and ecstatic to receive their homes and kind of see it come to the lot. Some also travel to the foundry to see it there, but not always and not all the time. These will be replaced by hydro flasks in the near future as well. This is another project site. This is in Ventura on a hillside. There's some better shots seeing the view from there, but this is the first module pulling up and ready to crane into place. Pretty massive crane there, but these we had some pretty heavy modules on this project as well. And here's the panoramic, seeing the valley there below. This is looking to the south, and this is the third module going in place, and there's one left after that. We'll see from the front side. You can kind of see the sequencing of the process, working from one corner, back corner, and then from back to front is the typical process. But it kind of depends on roof overhangs and other conflicts that can come into play with the swinging of the crane. So, and there's the last mod set on that project. So you can see everything's been set. That usually happens by 12:30, 1 o'clock for a 4 or 5 module house. And then we can start our stitching process. We're usually air sealed by the end of day 1, and ready for some of that thermal layer to go in, the continuous exterior insulation filling in, and the gap between the SIPS panels getting filled in that second day, along with all the structural connections that need to be made, ahead of landing that thermal. Just some more of the close-up shots of some of those stitches. So here's a inside corner. You can see the wall. Then we have the rim joist and the foundation. So it's all getting sealed for Soko. There's backer rod behind there, as you can see here as well in the top right picture. This is the roof side. We've since changed our detailing a little bit here. We had the spray wrap MVP and the blue skin to protect that. We would never consider performing a crane day operation in a big rainstorm, but there might be a marine layer or something like that that would come in or be in effect. So just ensuring we have kind of a little bit of redundancy built in place and some protection, give people the ability to walk on it and still protect that layer below there. But you can see the back rod goes in, and then we follow that up with the joint and seam and then strike that with the tool and get that nice concave bead. And then again, redundancy, after that Prosoco cures, we tape that off with a high performance sealing tape. That bridge the gap here between the foundation and the rim joist. And here's a finished picture of our garage and our battery and solar inverter install, which is pretty cool, pretty exciting part of the project for myself and a lot of the people in the passive house world and our clients especially. We've heard some good stories about people, not even knowing they had an outage when they're backed up by solar and battery together, which is great to hear. And then this is our solar array on that project. This is the last one we saw, the crane, same house. And this is an 8.4 kW array. And so and the battery was a 12, so I think that was a 15 kWh battery. So that's where we start. And then those units can actually scale all the way up to 20 kWh. So people can add additional cells in there and boost that depending on their storage needs. And then next comes our Dvele IQ. It is our own proprietary software program that kind of links together all of our sensor inputs. So we have a few hundred sensor inputs that are all reporting back through this. One of the neat things about it is that it stays secure. We view privacy as a health and wellness feature. And so ensuring that data lives on site, there's a hard drive on site and that's where it all gets reported to, and the decisions tree that gets made from it all gets stemmed from that computer that does live and operate this system. The clients do have the ability to opt in or to send us notifications if there is a red flag on a dew point sensor or something like that, for instance, so that we can start addressing it. But that's their ability to control. So again, privacy, I think, is only going to get more important as time goes on with security. So we wanted to have that at the forefront of our program. And then getting into some commissioning, and I know everyone here might want to see some statistics. So here's our FIAS Plus 2018 kind of report showing the heating, cooling demand. This is the house this is actually in Ventura, California. So pretty mild climate, but definitely meeting all of those needs there. This is a graph just showing the solar and battery production storage. So we have, your early morning hours just consuming before the ramp up of the PV production. You can see early in day, there's not a lot of use, so we're just building charge in that battery. The battery is currently set, sorry, I think my gallery window is blocking me here, to about 65%. So that's just based upon customers' preference, how much they want to have in backup mode in case there's a grid outage to get them through that. And you can see based upon their production during the day and their use during the day, that they discharge all during peak power, basically don't have much of a need for the grid for that peak power hours. And then, after that battery drains, it only drains to 65%, they start using grid power again. Again, they could definitely toggle that down if they didn't, but not knowing when there's going to be an outage, they just wanted that extra security blanket. They both work from home, so it works for them. All right, and this is the blower result on that project. So you can see we had 190 CFM with the volume of the house that equated to, sorry, that's an errant 0, but it's a 0.55 ACH. Don't be too impressed. And then we have the new metric everyone loves, the 0.0216 CFM per square foot of envelope leakage. So,
which is the definition of an air barrier assembly, that 0.02 CFM per square foot. So you should be very proud of that number.
Thank you. And that takes us to the end of the slide deck there.
Wow, we have quite the question queue lined up. Susan started off and then piped in with 4 more questions. So she's got a total of 5, but we're going to hold her to 1 right now because as you can see, there is the list. Brandon, have a sip of whatever liquid you're drinking because it's going to continue here. Susan.
I would say, Sean, how about we all unmute for a second and just give a big cheers to the wonderful presentation.
Yeah, absolutely.
Cheers.
Brandon.
Cheers.
Thanks, Brendan.
Cheers.
Freaking
Cheers.
awesome, man.
Awesome.
Whoever said freaking awesome, you were the first person to swear. So I must tell you that you now owe the entire group a round at the bar. Whoever said that, you're responsible for the first round.
Mark.
Ouch.
He said
Mark, it's Phricken.
Freaking.
freaking.
Yeah.
Acceptable. All right, Susan, which question are you going to kick off with?
I think it's definitely the Prosecco. I just want to educate everyone that Prosecco is a type of champagne. And no, I think a lot of my questions got answered. I sort of jumped ahead. I was interested. Thanks so much, Brandon, for this. It's really nice to see this getting assembled in the shop. Can you talk a little bit about it? I didn't write this question, about any the challenges that you're having, or maybe you're not having, what it's like to be selling this product. And I think my understanding is the challenge is that you're dealing with all the guys with their tool belts and pickup trucks and whatnot. And can you talk about those challenges?
Sure. Yes, the initial challenge was, like I said, mentioned, having acquired a facility that was already producing both modular and HUD code homes, and had their own, had been a long history of doing that. So for us to come in and immediately increase performance metrics and standards and introduce new detailing and things like continuous exterior insulation was part of our process from very early on. Just having to go through those steps and processes. So we created manuals and scope of work items, a lot of drawings and detailed drawings to give direction and a step-by-step procedure to make that more easy and palatable. Also, showing people what the performance testing on the back end was going to be, and that it wasn't just like once it gets covered up, no one's ever going to see it again, because that's kind of the norm in that industry is, once the siding's on and the drywall's on, like you're moving on to finishes. And the fact that we can see behind walls, for lack of a better term, with using some of that testing equipment, kind of shed a new light on and kind of gave people the aha moment that, okay, well, there's something different here, and it's actually be measured, and we're going to be held accountable for not only the process here, but once it gets to site and gets put together, like it's all going to work together and where those things are happening, right? So that was the first part, and then the same thing, but going on to the site portion of the project as well. So currently we've built out in the geographic areas that we are focusing in, having site partners that we've trained, developed quality control standards for. They're required to fill those out and send those back to us as the job progresses, so we can kind of check on that along with photo documentation, and then site being on site and seeing it firsthand too with our own employees. All very important parts of the process, but created what we call the stitching manual that basically, again, breaks it down very detailed, step by step. Once this home is delivered, what needs to be done to actually bring it to completion. And then it actually goes into, again, that performance side of it, what the performance metrics should be when it gets tested, and how we test for those metrics. So just trying to give people that education early on, and it has to be early, but also often, and continuing to reinforce those and show people. And I think every time we've done a blower door on a project, we've had different crews or bringing different people up from the factory to actually see it on site. So again, just they understand, and they can bring those stories back to the rest of the crews at the foundry, and ensure everyone's on the same page with.
Thank you, Brandon. That's great. Hey, Sean, how many am I allowed to ask?
That's it. You actually, you had 5. You pulled an audible, so you're in the back of the line, because we're not playing football rules here. So back you go. Chris Brown, off you come.
Wow, Sean's spicy today. I noticed a number of people.
Feisty with a PH, Chris.
Yes. Well, I had said spicy, but since he's Canadian, probably not spicy. All right, so I noticed a number of people had asked similar questions about transporting these modules and components after you have them assembled. Certainly I would expect that you would have a very stiff layered product. And, I was wondering about how do you keep the seams intact and all of that in the shipping process, getting them on site, making sure that you haven't had any damage during the shipping.
So all of our homes, like I said earlier, they're all structurally engineered, for seismic, but also the structural engineering teams are taking into account that shipping process and what are those vibrations going to look like, and making sure they've taken that into account in their calculations. So that's one part of it. But all sides of the box have shear on them as well. So that helps, also reinforce that rigidity. The suspension on the chassis are an important part of it, or, mod trailers as we evolve, just to give as much, flexibility to that process as possible. But, when it arrives on site, we track like where the drywall cracking is occurring. There's always some cracks in the drywall. It's easy to fix, but we do, take good note on exactly where those are occurring. So as we build more data points, we can continuously improve what we're doing and, design other solutions around that.
Quickly with that, Brandon, is your drywall a 5/8 product?
It is, yes.
Just because I love this kind of detailed prefab stuff. When you guys are drying it, are you guys using automotive dryers, or do you just keep it drying the same kind of, typical job site conditions of 12 hours or 14 hours, or do you superheat it to dry it faster in your factory?
No, it's, I guess, a luxury that we do have is where our factory is, and it's in a very dry climate, right? So kind of out there in the desert. So we don't have, we build under roof, so we don't have that moisture risk during that manufacturing process, and then everything gets sealed when it gets shipped. When it gets to site, we'll throw in, just smaller level, dehumidifiers or humidifiers, depending on where it's going, and, heating units or cooling units, just to keep it, consistent through that stitching process until delivery. But we don't want to find our ERV or our final mechanical systems for sure till the very end, until everything's been final cleaned, 2 or 3 times before we take off the caps on that system.
Okay, and that's my only one question. I'm sorry to butt in there, but I love this. Like, Brandon, you're on fire. This is great. Mr. Scott Kennedy, you have a couple questions. Please choose one.
So my question, I'll take the Prosoko question. It's a wet product, and we actually toured our office through the BCIT High Performance Lab that Sean toured all you guys through the other day. And I did ask the question because there is a Prosoko assembly in there, and they said their guys did not like working with that product, that it was goopy and sticky, and I was just curious as to, because we've been speccing it on it, but we haven't actually had it accepted on any jobs yet. And I was just curious what your guys' experience is with the Prosoko.
Yeah, personally, it was, I had been using when I was building Passive House on site. So it's something I'm very familiar with, and, had tested several different products and different assemblies. Actually, more than several. I think every single Passive House I built in Chicago had different assemblies and different, insulation types, and just was constantly, playing with that stuff to try to refine and, bring it into whatever the customer's values or that project's values were. But yeah, having experience with it, definitely it's a unique and new element. And, but we've assigned certain people on our production floor that, trained, I trained them. We also had someone from Prosoko come. They actually gave them another training. We did the mock-up walls. And then, we have just a limited number of people that actually get their hands dirty with that. But it only takes a couple times and a couple stained clothes before you figure it out, right?
So do you do as a roll on? Is that what you're doing? Is rolling it on, or are you spraying it on?
We are rolling it on, yeah. So that product was showing the spray wrapped MVP, and we've since changed that to the Cat 5. So
okay,
yeah, all roller applied, and like I said, it's roller applied, flat before it goes up, just to try to create that sub-assembly station.
Oh, so you're rolling it onto sheets flat, and then putting it, or are you rolling it on the walls flat, or are you rolling onto sheets flat that are then nailed on?
On the sheets flat, and then then those are subsequently nailed on, and then sealing those joints.
Okay, all right.
So just to chime in to give some insight, Proseco has a spray product now that's available that's a lot thinner. It's thinned out to go through the spray machine. And it's also that same product is the preferred product to roll on as well because it lays out really nice. But really what Brandon and his team are doing is they're manufacturing a product in their shop. They're taking the board and they're coating it with the material that some other manufacturers have, and they're using the Proseco product, and then they're detailing the seams. But just to bring awareness of their level of air tightness, which I tried to hint on before, 0.02 CFM per square foot of surface area is the air barrier assembly test criteria for the ABAA. So you cannot be an air barrier assembly unless you are below 0.02. And his entire building is meeting that level of air tightness, which is remarkable. That's including windows and everything like that. So it's quite the achievement. The 0.55 sounds like, to us passive house nerds as something that, he just got under the passive house level. He's doing a single story home. The surface area to volume ratio is not in his favor. And when you come to air tightness, he's knocking it out of the park. The FIAS level of air tightness is 0.05. So he's well below that number. And, they're doing a very impressive job. So
To add to that, Scott, this past summer I toured Build Smart, and they spray the Proseco on the same way that Dvele is doing the roll on. And in my personal experience with the Proseco, it's not something I give to the carpenters to do. I usually from a self-perform aspect, I have one of the drywall guys go ahead and put on that detail because they're used to moving fast and they're used to not skipping a spot. They know how to note imperfections and move quick. So it's all who you decide to be the ass on the job.
Mark, are you name calling again? You're so mean. All right,
No,
Scott.
it's just a heads up. Next week we have smart ass tools. So
Foreshadowing again, are you? All right, Mr. Gal Spanier. Hopefully I see your name right. If I didn't, you can hit me through the video. It's okay. It's happened before. Tom Bissett is left. I'm not going to give it to Susan, so we're going to skip Tom. Jane Sanders has 3. Jane, pick one, and then we'll put you back in the queue because we got a long list tonight.
Hi, I was just wondering if you've done like WUFI analysis or looked at the wall assembly for different climates. And I noticed that it was a foil-faced insulation on the outside, and are there any issues with that as a vapor barrier?
Yeah, so we did, that was something we kind of exhaustively did early on, was looking at different wall assemblies and running them in WUFI. We wanted to make sure we were trying to model things that worked from an energy perspective, but also a building science perspective, and making sure we didn't have moisture related issues with our assembly. So we also being focused on the fact that we're trying to build a manufacturing line, and we can't make too many alterations, especially on something like the building assembly that vary depending on where it's going. So we modeled all those and looked at cities all across the United States and through our building in all these different areas, ran those WUFI models to make sure that it was going to be a safe assembly that was going to work in all those locations. And yeah, it ended up working really nicely that way. So we started with our first home had we actually used 2 inches of a polyiso and then 2 inches of EPS after that, trying to protect the polyiso from condensation, and looked at that. But we lost too much depth on our interior living space. So, we had to kind of massage that point between having a really good habitable, livable space with good dimensions of a room with the depth of our assemblies and trying to achieve that. So also, getting that R16 and the 2 inches was pretty powerful for our energy side of that equation.
Jane, does that work for the first question?
Just to help with that a little, you guys are only shipping to only to the middle of the country, right? You guys haven't gone to the East Coast yet, or even Midwest.
That's correct. Yeah, we've mainly focused in California. Most projects are here, and like I said, also looking at some areas in Utah and Colorado, but that's primarily where we're shipping to today.
So mostly dry climates and mostly climates that require an exterior vapor barrier
Okay, Jane, it is time for Brandon to talk about his mentor. So I'm actually, Brandon threw an Audible in and created this slide for you. And because I got another one that we may play with, but at least you can talk about this one. Who are your mentors?
Yeah, so it's hard for me when I was thinking about this question to just single out one person. I could do that, and there might be others that felt like they could have been in that role. So, for me, it was definitely the whole community, and really the passive house community, the building science community, Living Future, the open sourceness of these different communities and these different groups of people, all focused on doing things better at it, and not just a little bit better, but exponentially better. And the fact to have those relationships, access to some really really high level, brilliant people to talk through these ideas with, as I was early in my career up until the present. It's been a continual process and continuously learning, and really engaging in those communities. But those communities have really inspired me, and given me the education, given me the background, and reasons why, the science behind things. It's been a great process. To say it takes a community to raise a child, well, it's taken a community to bring my passion and all that fully forward, and be super proud of the products that we're releasing now.
Great. Brandon, I always bring into the conversation that being in building science and attending summer camp and learning about passive house is like joining an Olympic training center for building, meaning like you're surrounded by the best and people that are going to help you become the best. And you're having that conversation of that steel sharpens steel, and you're really honing at that leading edge. And if something that stuck out in me the first time I heard Joe talk at summer camp was that innovation and excellence happens at that leading edge. And we in the passive house community are that leading edge. And it's great to see that you've penetrated the modular market, and to see that that's possible, because I could, like in the East Coast here, I mentioned modular and passive house, it'd be a hard sell, and you guys are rocking it, and it's great, and I hope that it comes east, and it's something that we need. So keep up the good work.
Yeah, thanks,
Your
Kevin.
data.
Really, it's the openness of the community too, to share both ideas and lessons learned, but also what didn't work, and being open about those kind of things have made learning curves for others, including myself, easier to get over and through. And that's how we
Hey,
iterate.
Kevin, if you're comparing the passive house community to the Olympic training facilities, is it fair to call the Accelerator the HGH?
I don't think so.
Oh, come on.
We're not doing anything illegal. This is pure. If it was HGH, I'd be down.
HGH became illegal much later. I mean, come on.
Passive house human growth hormone. All right, I'm down with it.
It is performance enhanced housing, right?
There you go.
See, there we go. All right. So before we
PEH, there you go, Brandon, for the win.
So before we turn it over to Zach, and before Brandon shows the real tools in his tool case, right, Brandon? These are your three smart ass tools that you always work with, right? Right. These are the guys that hang out with you, right?
Well, no doubt, no doubt.
Okay, Zach, take. All right, Zach, take it over.
All right, I will. Thank you, Brandon. That was awesome. And thanks everybody for being here. We have some announcements of some great programming coming up. But first, I want to just say that none of this would be happening without the support of these fine folks on your screen right now. So I want to give a very big shout out to our sponsors. Our founding sponsors are 475 High Performance Building Supply, Baxtingui Architects, Glavel Foam Glass Gravel, Minotaur, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Stocorp, and Zola Windows. Our stakeholder partner is NYSERDA, and our patron sponsors are BR+A Consulting Engineers, Brennan Insulation and Airtightness, Inotech Windows and Doors, and US Engineered Wood T-Stud. So tomorrow right now actually, we have our Passive House podcast episode live. Just went live yesterday with Sean Taylor of Team Green Architects in New Zealand. This is a great interview with Sean and co-host Matthew Cutler Welsh. Please check it out. You don't want to miss it. Tomorrow, the Global Passive House Happy Hour will feature Amy Fiella of Bax Ingui Architects, and she's going to be talking about this super cool passive house retrofit of a historic firehouse in New York City. On Monday of next week, on February 15th, we've got our Passive House Retrofit Summit, which will feature a bunch of leaders of the North America's kind of most exciting retrofit programs. So you want to check that out as well and learn about the kind of incubators for retrofit work in Passive House in North America. And then we have Kevin Brennan with the smartass on the Construction Tech Tuesday next week. And our happy hour next week will feature Dennis Wedlick of AIA New York, the CRAN, and that is the Custom Residential Architects Network. Dennis is a pioneer of passive house design and is especially focused right now on passive house for Habitat for Humanity and eliminating energy poverty through passive house. So lots of great stuff on tap. Please join us.